is entropy balance for it's going to be actually entropy rate. Control volumes. Okay, so just a reminder, what is a control volume, Shabab? So a control volume, a system where we have, if we have a boundary here, okay, and this is our system, we have mass crossing the boundary. So for a control volume, the mass must cross the system boundary, okay? So maybe you have Q, maybe you have work, volume, okay? So just a reminder, what is the mass balance, ya shabab, for control volume? So the change of the mass of the control volume, okay, or the rate of mass change of the mass within the control volume equals summation of all mass flow rate inlet minus summation of all mass flow rate. Okay, so this is the mass balance. And here, Shabab, for the entropy rate balance, it's going to be very similar to what we discussed before. If you remember, for the closed system, what was the entropy balance? Was the change of the entropy within the system equals the Qi over Tj. Remember, this is in the rate form. Okay. All right. Plus the entropy generation term, I will put it here. Okay, the entropy or the rate of entropy production. Now, the new thing here, ya shabab, what is it? What will it be?
Mass. Entropy inlet.
So the entropy will transfer. The entropy will transfer from the heat transfer, right? The entropy transfer because of the heat transfer. This is the term here. And then we have entropy production here. But then it will also transfer because of what? Similar to the flow work, if you remember, for the energy balance. Yes, because of the mass. So the mass inlet and the mass, okay? So in this case, what is the corresponding term for the mass inlet? So we just multiply the mass by the entropy, as simple as that. Okay, so we have m dot inlet is inlet minus summation m dot exit s exit. Let me increase this. Okay, so this one here is the rate of entropy transfer due to mass inlet and mass exit. This one here, this is the rate of entropy transfer because of the heat transfer, and this one is entropy generation or rate of entropy production within the control volume. Okay. أي سؤال هنا؟ أي سؤال؟ So this is the basic equation for the control, for the rate balance, entropy rate balance for control volume. All right. وضحت يا شباب؟
واضحة دكتور.
Okay. طيب, when we have a steady state, for a steady state, for steady state, okay, so what happens for a steady state process or for a steady state flow? When we have a steady state, so the rate of mass change with time and the rate of entropy change with time is 0. So in that case, I have 0 equals summation Q over T plus summation M dot I S I over inlet minus summation M dot E S E over exit plus production term. Okay. For the mass also, what we'll have, for the mass, we will have, this is 0, and then we have summation of M dot I equals summation of M dot exit. Okay. So this is for a steady state process. Any question?
يا دكتور الجي ايش تمثل؟
كيف؟
letter for J.
يعني if you have multiple خلينا نقول temperatures or multiple heat transfer at different locations with time, you have different يعني this is the J, and you have multiple locations. You might have, for example, point 1 here, point 2 here. Here. So yeah, you might have, let's say, number 1, and then you have point 2, and each one has different heat transfer and temperature. So it's just a summation over the whole boundary. This is just summation for the whole boundary. Okay. طيب يا شباب, let me ask you a question. From this equation, if you look at this equation here, is entropy conserved or not?
ايه يا دكتور؟
ها؟
عاد السؤال بالله.
I'm saying, is entropy conserved? If you look at this equation, the entropy rate balance, is entropy conserved or not? And this is an important concept. If you look at this equation, let us write this equation this way. So for the steady state, m dot exit is exit equals s m dot inlet is inlet plus q over t plus sigma cv rate of production. So what do you notice? What do you notice from this?
The inlet plus the generated entropy.
So the entropy transferred out of the system, if you notice, it is what? It is more than the entropy transferred into the system. And if you look at this equation here, for the mass is conserved. Whatever mass goes in, it must, yani same as mass goes out. Okay? The same thing for energy. Energy is conserved. Whatever energy goes in, you cannot produce energy from nothing. The difference here يا شباب إنه entropy is not conserved here because there is يعني from this equation we see that entropy transferred out of the system is more than the entropy transferred into the system. Okay? So this means entropy is not conserved. Okay? And this is the difference between entropy and other properties, like mass, energy. Okay? So this is يعني important to know. أي سؤال على هذه؟
But doctor, we said before that according to one of the statements that we talked about conservation of entropy, right? Before.
Entropy balance. Entropy, so
that ds
I
by dt is
I understand what you are saying. So first of all, what we're talking about open system. Okay, this is the first thing. The second thing, I have entropy balance. Yani I can see, I can balance my system, or I can balance the entropy in my system. But the point is, if I have an entropy that goes into my system, is not necessarily this same entropy will exit. You know my point? You see my point?
Yes.
Yani entropy, because of this term here, I am generating entropy out of nothing. Yani. If I have irreversibility, I'm generating entropy. That's why it is not conserved. حتى from
I was referring to the equation ds by dt equals s input s dot input plus sg input sg dot generated within the
هذه
system.
نتكلم على closed system.
اوكي هي تقريبا نعم كانت ايوه كانت في كل سيستم هي.
Yeah. No, I'm talking here about the open system.
Yes, okay.
Okay. حتى شوف حتى في الكلوز سيستم يعني for the closed system تمام if we have that equation okay if you notice لو حطينا هذه zero you still have what you still have even you don't have any entropy. Let's say you don't have خلينا نقول if you have heat transfer okay and G sorry production sigma, are these equal? Not necessarily. فهمت قصدي؟ يعني I'm
Yes.
generating entropy out of nothing. I'm not bringing it in and then balancing it or يعني conserving it. Okay? So this is important.
يا دكتورة ذكرت لنا هذه المعلومة في الشابتر 5 يوم قلت لنا الصراط المستقيم وإبليس قلت لنا
أيوة.
الكونزرفيشن في انتروبي
أيوة.
تي اس اوفر دي تي يساوي اس الاي الدوت بلس اس الجي الدوت.
يمكن يمكن الفورمولا أطلقنا عليها conservation in terms of balance يعني balancing the equation or balancing the system. But it doesn't mean entropy is conserved. That's what I'm clarifying here now. Okay, maybe the way I called it is confusing before, but the point is I can write a conservation equation or balance equation. That's okay, but it doesn't mean entropy is conserved. ترى في فرق. When I write a balance equation, I write a balance between two sides. It's different from this quantity is conserved or not. That's, I guess, what I'm clarifying now. Does that make sense?
Yes, Doctor, thank you.
And it's good to relate things to previous information. طيب, quickly, for one inlet and one exit, for one inlet and one exit, okay, and the steady state, and we can simplify the equation also for one inlet and one exit running at steady state. So you have 0 equals summation Q over T plus M dot. So since we have one inlet, one exit, M dot inlet equals M dot exit, so it's equals to M dot S1 minus S2 plus sigma rate of entropy production. Okay, so this is the equation for the one inlet, one exit, and steady state. أي سؤال هنا؟ So if I want to find from this equation, if I want to find the entropy change, which is what? Let's say S2 minus S1, okay? S2 minus S1, this is gonna equal to 1 over M dot, summation over multiple locations, okay, plus over M. Okay, so
دكتور,
yes,
we usually have one inlet, one exit.
يعني this is sometimes this is what we usually have, yes, like for applications, except if you have, let's say, feed water heater, which will have multiple inlet, multiple exits, then you can apply the other equation. But if you have a system with one inlet, one exit, you can think of this equation. يعني, if it is at steady state, you can think of this equation or this equation. Okay. Just another reminder that this term here is greater than or equal to 0. Okay. The same thing applies for this term. Greater than 0, that means S2 is greater than S1. If it is less than 0, that means S1 is yes, S1 is or S2 less than S1. Okay. If it is 0, that means S2 equals to S1. Okay. And if S2 minus S1, أو خلينا نقول if S2 equals to S1, this is isentropic process. Okay, so just this is a quick reminders here. Any questions? Any questions here?
No.
Let us take a quick example. Let us take a quick example here. Let's take a quick example. So this is, yeah. I guess this is a turbine. Okay. So this turbine has a boundary with a temperature of 350 Kelvin. Okay. The pressure at the inlet, P1, equals 3 megapascals. Okay. And the T1 temperature of the inlet, okay, is 400 degrees Celsius. Let me just double check. This should be water, okay? So water flowing through, or steam flowing through turbine, right? So we have steam to generate power. So at the inlet, its pressure is 3 megapascal and its temperature is 400 degrees Celsius. And its V1, or velocity at the inlet, is 160 meter per second. Okay. At the exit, so state 2 or exit 2, the steam becomes saturated vapor at 100 degrees Celsius. Okay. And it has a velocity V2 equals to 100 meter per second. Okay. So if the work generated, and this is part of the question, if the work generated per unit mass is equal to 540 kilojoule per kilograms, okay, find the rate of entropy produced by this turbine. Okay, so we want the entropy production term, or the rate of entropy production. طبعا شباب انتم عارفين الفرق لما نقول لك find، حتى لو ما انا الحين ملخصها بالسيمبلز، but in the question if I tell you find the rate of entropy production, you should understand that I mean the sigma. Okay, it's different from the S. S is entropy. Sigma is entropy production within the system. Okay, so how can we proceed in this case? So I want this here, this term here. So what should I do?
Write the entropy balance equation.
Entropy balance equation. See what
So
we are missing.
Exactly. So let's write. So this is. So by the way, this is steady state. يعني it's running at steady state. So let us write the entropy rate balance for steady state. How many inlet? How many exit?
One inlet, one exit.
One inlet and one exit. Okay. So it will be 0 equals. Since this is the boundary, I will consider it all at one temperature. So I can say I have just rate of heat transfer divided by temperature of the boundary, okay, plus m dot S1
S2
minus
minus S1.
yes, S1 minus S2 with plus here, and then plus sigma of the control volume. Okay, so if I want sigma per unit mass, so basically I divide by m dot, okay, which will equal to S2 minus S1, right? If you change it to the other side, it will become minus, so then you can flip this one. S2 minus S1 minus اللي هي ايش؟ Q dot over TB over M dot divided by M dot. Okay, so this is now the equation that I can use to evaluate the rate of entropy production. So what are we missing in here?
We need the Q.
We need the rate of heat transfer. What else?
We need entropy S2, S1.
So we need S1 and S2 at these different states. At state 1, the pressure and temperature, and state 2, this phase temperature. Okay. وضحت الفكرة؟ So we need rate of heat transfer at different states, state 1 and state 2, we need the entropy. So what is the way to calculate the rate of heat transfer?
Energy balance for steady state.
ممتاز. So the equation that includes the rate of heat rate of heat transfer is the energy balance, right? So the energy balance for a steady state, okay, and one let one exit. What was it? Q equal Q dot
minus W dot
minus W dot
plus MI HI.
خلاص احنا we divided by M dot, so
Okay.
we're and we can ignore potential, right? So we have H1 minus H2 plus this is the
V2 V1 minus V2
V1 squared over 2 minus V2 squared over 2. Okay, هذا يا شباب ترى you should remember it يعني you should memorize for a control volume, for a steady state, like that. Okay, so as you can see now, if we want Q dot over M dot gonna equal to, right, plus it's gonna be the opposite here, H2 minus H1 plus V2 squared over 2 minus V1 squared over 2. Okay, خلاص. So we have the equation to calculate the heat transfer, the rate of heat transfer per unit time. I have this one at S, I have this one, and I just need to go to state 1. Find what? Find S1 and H1. Okay, go to state 2, find S2, find H2, and then go back here, substitute to calculate heat transfer, and then come back here to calculate the rate of entropy production.
دكتور التي بي لازم تكون بالكلفن صح؟
Yes, of course. What is TB? It's this one here. 350 Kelvin. Okay. So you see how systematically, if you are clear, خلاص, you know exactly what to do. Okay. Start from the end. Start from what's required. Put that equation. See what's missing, and then go back and calculate what you need. Any question here? Any question? خليني بعطيكم ال final answers, and then you can work it out. So the Q over M dot is going to be equal to minus 23.9 kilojoule per kilograms, and then the sigma over m, or sigma dot over m dot, is gonna equal to 0.499 kilojoule per kilogram Kelvin.
Doctor, what about the unstudied state? Is it more complicated or
Well, sorry, what about what?
the unsteady? What if it was unsteady state?
Unsteady.
Yes.
For the unsteady, if you remember, it will not be m dot. We will talk about m, and then we will have mhi, if you remember, for the energy balance. The same thing for the entropy balance. It will be ms instead of m dot. So you need to solve that differential equation, then find the entropy balance. So the same as before. But here I'm focusing on the steady state. Okay. Because many of the processes, or most of the process, we have a good number of applications that use steady state, like a pump, compressor. They usually run at steady state. Okay, so that's why I'm focusing on steady state here. Like in principle and theory, is similar to what we talked in the energy balance. If it is unsteady, eventually you will have the change of delta U, if you remember, for the energy balance.
Yes.
Yeah, equal Q minus W, and MIHI summation minus ME HE, and then for the entropy balance, the same thing.
The entropy balance will not change.
لا, the entropy balance will still be M. it will be different. So it will not be a rate form.
Yeah. Rather than that, it will not change.
Yeah. غالبا يعني. خلاص بيكون عندك تقريبا دلتا اس equals اللي هو ms inlet minus ms exit plus sigma. Okay. Good question. Any other questions? Any other questions? Let's see. طيب, the second thing that I will talk about inshallah more in the next class is regarding the isentropic processes. Okay, so we talked slightly about the isentropic process. Isentropic processes. Okay, and for the isentropic process, we said the S1 equals S2. Okay, so I want to look at that for ideal gas model and how we can use the ideal gas table. I think we talked about this, Shahab, صح? Let's see if we have.
You mean an S dot or something? Less اللي فيها.
So we talked about the S note, right?
Yes.
Yeah. So I'll just give you another summary of that, okay? For the ideal gas model, and then using the ideal gas table, and then for constant specific heat, and for example, ideal gas, yes. Yeah. So we'll just review the ideal gas model with isentropic process and a polytropic process. Okay, which is similar to what we did before, and then we'll give an example about that, or a couple examples, inshallah يعني. If we have time, then we'll quiz يا شباب الكلاس الجاي. It will be 8:30. All right. خلاص ويبقى لنا بس اللي هو last topic اللي هو how to calculate the efficiencies. تذكرون يا شباب التوربينز الكمبرسورز النوزلز diffusers.
Yes.
So we will calculate اللي هو we call it isentropic efficiency. Okay. So the isentropic efficiency is the efficiency for considering isentropic process. يعني assuming the process running through this device is isentropic, and then we calculate the efficiency for that. Okay. So we will look at that inshallah next week, and that should be our last topic in this semester inshallah. Any questions here before we end? Questions? Okay, Shabab, if you don't have any questions, good luck, Shabab.
يعطيك العافية.
Bye.